This pyramid may look simple, but the geometry is actually impossible in our normal Euclidean space. Because this pyramid contains three different inner sides, which on the one hand share the same space, but on the other hand are somehow separated. Hi, I'm Pape-Lange, and today I will show you how to trick Blender into rendering this impossible pyramid using a nice compositing trick. With this trick, you will also be able to create portals in which both sides can shine and reflect light onto the other side. Also, we will only use some additions and subtractions on RGB values, which means that this trick can also be used with Eevee. I will start with a key observation. Afterwards, I will show you how to arrange the compositing nodes to use this key observation. And in the end, I will show you, for the sake of completeness, how to do the modeling. For the main idea, let's compare the pyramid in which all sides are closed to the pyramid in which exactly one side is open and the other two sides are closed. In both pyramids, the closed sides are blocked with perfectly black triangles which absorb every light ray hitting them. The most notable difference between this image and this image is, of course, that in this image we can see into the inside of the pyramid. We could implement this, for example, with chroma key, or in Cycles we can even use the cryptomat. But we also have the reflections on the mirrors, the rough walls and the floor. This also includes the reflection of the right wall in the left mirror. So let's look how the inverted light rays from the camera to the light sources behave. If a light ray does not enter the pyramid, it doesn't matter whether the pyramid is open or closed. The color which reaches the camera will be exactly the same. Therefore, the only difference occurs with the light rays entering the pyramid, or in the case of the closed pyramid, hit this black triangle. If the light ray hits the black triangle, it gets completely absorbed. So the only difference between the two images is that there is potentially more light if the pyramid is open. Also, we can measure the additional light by calculating the difference of the two images. Therefore, our goal for the compositing is to add the additional light of this, and this render onto the render of the closed pyramid to get the final image which looks like this. We also want to ensure that this difference is actually at least zero. This way, we can also hide whole galaxies in the pyramid, which mmorky2 did in his interdimensional triangle, which is linked in the description. We can also get away with scrappy modeling, which results in having one bar of the pyramid be thinner with the open side than with all sides closed. This explanation doesn't quite work with Eevee, because Eevee doesn't rely on ray tracing. For example, this closed pyramid reflects a bit more light than this open pyramid. However, the final image with the compositing looks very similar to what we would expect if we just took the simple open pyramid. In order to model the impossible pyramid, it is useful to understand the composition first. For that purpose, I prepared this example pyramid. As you can see, we have 4 view layers, one for each side and one for the closed pyramid. We will combine these view layers with compositing. In the compositing tab, we have the compositor and the dope sheet. Since we don't need the dope sheet today, we can remove it with right-click and join areas. After we enable the nodes, we get a render layers node and a composite node. The composite node will contain our final image, and the render layers node outputs the render of a given scene and a given view layer. Since we have 4 view layers, we also need 4 render layers nodes. With copy and paste, we can add 3 more. We also want to match the view layers of the nodes with the view layers we have. So one for the closed pyramid, one for side 1, one for side 2, and one for side 3. We also want a preview of what we are doing, and we can either add preview with add output viewer, or if you have node wrangler enabled, we can Ctrl Shift left click any node to preview the output. As you can see, the render layers node does not have an output yet, because we haven't rendered anything. With F12, we can fix this. After rendering, you should now see the image of the viewer in the background, and all render layers nodes should produce an output. You can verify this with Shift-Control left-click on any of these nodes. Apparently, changing any of these connections also adds the previews of these nodes. Now that we have our inputs, it's time to calculate the differences between the images with one side open and the image where all sides are closed. The easiest way we could do this is go to Add, Color, Mix, and set this mix to Subtract. However, without clamping, this could yield negative color values, and with clamping, we are limiting the maximum brightness. So we can do better using mask nodes. Before we can use mask, we first have to separate the image into RGB values. So we go to Converter, Separate RGBA, and we need this for 2 images for the difference, so copy and paste. Then we do some mask, and afterwards we convert it back into an image. So Converter, Combine RGBA, and in between we have Converter, Mask, and we want a difference, so we select Subtract. The upper image is a dark image, the lower image is a bright image. We subtract the darker image from the bright image, so this is the right order. Dark image subtracted from the bright image. Again, we have the problem, without clamping, this could yield negative values. In with clamping, we have a maximum value for red. So instead of clamping, we use another mask node. So color converter, mask, and we set this node to maximum. And we take the maximum of the subtract and 0. So if the subtract value is negative, then we get 0. And if the subtract value is positive, then this value will become the new red value. We do the same thing for green and for blue, so copy and paste this 2 times. And again, we subtract the upper image from the lower image in both green and in blue. And afterwards, we have to connect this to the combine. Green and blue. And we connect this to the images. The upper one is a dark image with all sides closed, and the lower one is the image where the side 1 is open. And with Node Wrangler enabled, we can Control-Shift-Left-click to connect this with the viewer, and we see that this is the difference we would expect. Since we need this difference 3 times, it makes sense to create a node group, so we select everything and hit Ctrl-G. And the inputs are a dark image, so we name this first input dark, and the bright image, which we will call bright. And the output is the difference image, which we call difference. Afterwards, we can go back to the main layer, to the upper level, and we have to copy this node group, which we will call difference as well. We copy this 2 times for the other 2 images. So second difference, third difference, and we connect dark with the image where all sides are closed, and bright to the images where the second side is open and the third side is open. And again, we can Control-Shift-Left-click to check whether this actually looks like a difference, which looks fine. And afterwards, we want to add all 3 differences to the view layer where all sides are closed. So we take Add, Color, and Mix, and we use Add this time. So we add the image where all sides are closed to the additional light which occurs by opening side 1. This should look like roughly like just where side 1 is open. another add node for with copy and paste. We create 2 additional add nodes. Now we add to this image, the light which occurs by opening side 2. And we can see now we have side 1 open and side 2 open. And to this image we also add the light we get from opening side 3. And this is our final image. So we connect this with the composite node. Now we will model the impossible pyramid. We will need 5 collections, 1 for the outside world, 1 in which side 1 of the pyramid is open, 1 in which side 2 is open, 1 in which side 3 is open, and 1 where all sides of the pyramid are closed. So we will call them side 1, side 2, side 3, and closed. Similarly, we will need 4 view layers, 1 in which side 1 of the pyramid is open, 1 in which side 2 is open, 1 in which side 3 is open, and 1 in which all sides of the pyramid are closed. At this point, the default cube might think that it will survive the tutorial. Idiot. Now we want to add the pyramid, preferably a regular one, but if we hit Shift A to add the mesh, we see that the pyramid is not available. The closed thing would be the cone. Luckily, there's an add-on for this, so we go to Edit, Preferences, Add Mesh Extra Object. This add-on comes with Blender, and after we enable this add-on, if we go to Shift A, we see that we have a lot more extra meshes, and we go to Mesh Function, Regular Solid, and the first option is already the tetrahedron, so the pyramid with 3 upper sides and 1 side below. And we will scale it a bit up to size 2. This will be the outside of the pyramid, so we will call it outside. And with copy and paste, we get the matching inside, which we have to scale down. So S to scale, and 90% is a good value, so 0.9. Next, we want to create insets in the outside pyramid. So we select outside, the outside pyramid, go to edit mode, and select the upper 3 faces. We press one I for inset, another I for individual origins, and then we go to wireframe mode and set the thickness to some reasonable value, maybe 0.09. This should look fine. And now we have the insets, and next we do the materials. So we go to material preview and go to the materials. We need 1 material for the base of the pyramid, so because I take a metal, call it metal, set metallic to 1, roughness to 0.2. And this is already assigned. And I want the closed faces to be perfectly black, so I select all 3 closed faces with Shift Select. Create another material and call it black, and assign the 3 faces to this new material. And we want this to be perfectly black, so we go to shading. We remove the principal BSDF node, and I think black is already the default value for surface, so this should already be enough, but I take the diffuse BSDF node. And we have to set the diffuse BSDF to black, of course. Since we want the 3 closed faces to be perfectly black, holdout material won't work as material here. At least not for the compositing trick I presented in this tutorial. Now we can go back to object mode, and we see that we have already a perfectly fine closed pyramid, so we can copy paste this call this closed pyramid, and put this in the collection for closed. And we won't need this for now, so we can hide it. Next, we want to model the open pyramids, so we select the inside and the outside and press Ctrl J to join them. And we call this pyramid side 1. And in order to open this, we go to edit mode and we select one face on the outside and one face on the inside. And now we have to connect the lines which are parallel. So we select these two lines, press F to fill, select these two lines, press F to fill, and select these two lines and press F to fill again. We want another material for the inside, maybe pink, so add another material, we call it pink. And we select the three inner faces. Sign and make it pink. So if we have one pyramid with one side open, we want to use this for the other two sides, so we copy and paste this 2 times and put the pyramid side 1 in the collection side 1, and we can hide this collection as well. And we take the first copy. We could also hide the second copy, and we call this first copy pyramid side 2. And we want to rotate it with by 120 degrees in the Z direction. Also, maybe we want another inside color, so we go to edit mode. Causes instead of pink, we want yellow maybe. And set it to yellow. Oh, it's already assigned, so we didn't have to go to edit mode. And we want to put it in the collection side 2. And we can hide this collection, we can unhide the third pyramid, and we want to rotate it by the double amount, so 240 degrees. And for the color, we use turquoise. Oh, we have to rename it to pyramid side 3 and put it in the collection side 3. Now we can unhide everything. And we want, whenever we move the closed pyramid, we want the open pyramid to move as well. So we select all 4 pyramids and press Ctrl P to set the parent. So the closed pyramid becomes the parent of the 3 open pyramids. So whenever we move the closed pyramid, the other pyramids move as well. If we render the pyramid like this, even with the compositing trick, we will only see the closed pyramid. That is because we haven't assigned yet which view layer sees which pyramid. So the view layer of the closed pyramid should only see the closed pyramid. So we exclude side 1, side 2, and side 3. In the view layer with side 1, we exclude side 2, side 3, and the closed pyramid. In the view layer for side 2, we exclude side 1, side 3, and the closed pyramid. And in the view layer of side 3, we exclude side 1, side 2, and closed. This time, if we render and go to the Compositing tab for the preview, we see what we would expect from this camera angle with the usual Eevee lighting. Now let's go back to the closed pyramid and add some base plane to this. So in the world we want to add a plane, so Shift A, plane, and maybe 30 meter, and we want it to be metal. And we take the closed pyramid and lift it up so it's above this plane. So maybe to 0.75 meters should be fine. I already tested this. It's a bit hard to see. And the other three pyramids should also be raised by 0.75 meters. So side 1 is above the plane, side 2 is above the plane, and side 3 is above the plane as well. So this looks good. Now we want to put something inside pyramids. So we go to side 1, Shift A for add, maybe a little cube, 0.5 meter, and maybe 0.6 meter in the air, and a bit rotated. And we want this in side 1. And we want to be the pyramid side, the parent of the cube. So whenever the pyramid side rotates or moves, the cube should move with it. So we select the cube, we select the pyramid side 1, and we press Ctrl P, set parent to object. Inside 2, we add another object, maybe an icosphere of radius 0.3 maybe, also raised with 0.6 meters. We want to put it inside 2, and we want to set the parent to pyramid side 2. So Control click pyramid side 2 and Control P, set parent to object. And we want one object for side 3, maybe the monkey. 0.4 meters, 0.5 meters, maybe bigger, 0.6. And we want to raise it by 0.6 meters as well. Rotate it a bit. Put it inside 3 and set a parent. Now we also want to have some lights, maybe apart from the point light. So maybe a spotlight would be fine. Spotlight in the y direction minus 5 meters. Maybe 1 meter above the ground or half a meter. And we want to set the direction so that it illuminates the monkey. So we set an empty, Shift A, mesh. Where do we have the empty? Oh, here we have the empty. Plane axis and Z position 0.6. We put both in the word and set constraint to the spotlight. So object constraints, track 2, and target the empty. This should be fine, and we also want it to be maybe minus 10 meters. And we want the radius to be a bit smaller, so maybe, oops, not the radius, but the spot shape, the size. So maybe just 5 degree, maybe 7. We will see how it looks. And we want another spotlight, so copy paste. Oops. Want only the spotlight, copy and paste. Oh, because it's dragged to the empty, it's all so copied the empty. This is fine. And we want to set it to 10 meters in the x direction and 0 meters in the y direction. And let's look how this looks. So F12 to render. And this is not bright enough and maybe a bit too small. So, and the background is too bright. So we go to the world and set the background to black. The spotlights maybe to 100 watts, 500 watts, why not? And maybe the size a bit bigger too. And we also want to add some reflections. In fact, we should have done this when we positioned the pyramids, but we can do this in the render properties under screen space reflections. And now if we render, then we can see actually the pyramid we would expect. Maybe use a camera angle in which we can see in both sides. So we go to close because we have the parent here and rotate it a bit. Oh, toggle camera view. And we should see something like this, the two sides. So rendering, going back to the compositing for the preview, or just look at the render, and we see we can look in both sides of the pyramid, or 2 of the 3 sides. And that's basically how you model the impossible pyramid.